withstand space. Energy. We study oil and energy that is currently used as the general energy used. We study alternative energy sources. Our goal is to make life better for the general population, and so we use a lot of different ways to do that. And then we study life. Even though we're a magnet lab, we do have a lot of biologists here. We do a lot of experiments, including medicine, including diseases, trying to cure diseases that don't have cures yet. If you can think of any type of scientist, from biologists and chemists to paleontologists and astronomers, they probably have worked here or done experiments here. We're not just one branch of science, we cover a huge variety of science. And people that are here are pioneers in their field, and they're doing new and innovative things every day. And so the first magnet we're going to see, has anyone had an MRI before? So it's a lot like an MRI, just a little bit stronger. So the first part we're going to go through, actually, yeah, I'm going to go up the stairs, I think.
Okay.
So if you guys will follow me up these stairs, the very first part we're going through is administrative, so I just
Drew,
have to
please say me if a magnet
but
grabs
follow
me.
A magnet what?
If a magnet grabs me.
Is
Oh,
there-
yes, absolutely. It
Will
won't,
you
but sure.
take them on the elevator and meet me on the second floor? If you need to take the elevator, please follow Carlos. You guys do not need to take the elevator. Go upstairs. I don't care. Stairs are for everyone that can't take them.
You're not.
Oh, what you stopping for? Oh.
My shoe.
This man forgot to bring some tennis shoes.
It's fine. It's fine. I didn't know we were going to this place.
Yeah. Are you excited?
Yep.
And you fall. This is why
I'm
you
so
need.
excited about being here.
This is why you need closed-toed
I
shoes.
somehow missed a step.
There's just, I think, two that went up the elevator.
Okay.
Everybody else was A1 moves in. Awesome.
Maybe there's just like consistent metal floating in the air. It might drop. Or there's like the stone you turn into or whatever. Sure. Yeah, that's really cool looking.
Hey, Drew.
They got like smoking stuff.
Ouch. You okay? Yes, I am. Ouch. Are you okay?
I like how he's able to do that. Hey, me? My body.
Just a quick
Yeah,
guy.
and they spent too long because they didn't follow my example of going look, okay, I'm
I
good.
just did a quick peek at it.
That's okay. We just don't want to get away from the group.
Wait, by the way, I'm on YouTube.
You're on YouTube?
Yeah.
Awesome.
95% sure it is Let's Plays.
You just what?
Let's Plays.
I don't actually have Let's Plays. Not yet. But when I get like a higher depth camera, I'll get.
But the magnet is right through that window. It's got a lot of different things on it, and I'm going to explain them all of them mean.
Wait.
Did we get everyone that was on the elevators? Not yet. Okay.
Wow.
Oh, I wonder why. That would be cool if they did.
actually do.
Oh, no metal beyond that one.
So where did you guys write from? Charlotte County.
Or you have to wear some kind of like Faraday cage.
No.
Really good questions.
This is really good rock in our home, so I hope
Can you tell us that?
This is
Yes, I waited here. Yeah. I want to make sure. Do we have everyone? Awesome. So our first magnet is right through this window over here. Here, I'm gonna. So right through this window, you'll see the giant white cylinder. It doesn't exactly look like you would think a giant magnet. Some people might think the giant horseshoe with the red and blue, or a giant bar magnet that has an N and an S on it for our north and south. But most of our magnets are cylinders. They're giant cylinders like this. And so this is, actually let me back up. So really important word that I'm going to say a lot today is Tesla. Has anyone ever heard of Tesla before?
Yeah.
Awesome. Tesla is a great scientist, one of my favorites. So Dr. Nikola Tesla worked with Thomas Edison a lot in the 1900s. He made a lot of huge contributions to electricity and magnetism. He made a lot of really prominent discoveries. And so when he died, they named the unit of measurement for magnet strength after him. So when you say Tesla, you're talking about how strong a magnet is. So magnets on your refrigerator are 0.03 Tesla. They're not very strong, they're very small magnets. Junkyard magnets, magnets that pick up cars, are 1 Tesla. So if you see Transformers and you see the big magnets pick up the cars, 1 Tesla. If you had an MRI, as I know some of you had, those are 3 Tesla. So something to know about the Tesla scale, it's not normal. It's not 3 Tesla is 3 times stronger than 1 Tesla. 2 Tesla is 10 times stronger than 1 Tesla. And 3 Tesla is 10 times stronger than 2. So it goes up by 10 every time you go up. So if 1 Tesla can pick up a car, think about how much 10 Tesla can do.
Tremendous, like a building or
Tremendous
something.
This magnet is a 21 Tesla magnet. It is 21 Tesla. It's called the 900 megahertz. And the other thing it says is ultra wide bore. So we'll talk about what both of those mean. So the bore in the center of a magnet is where the magnetic field is. It's where we put our experiments to study them. And so this one is one of the biggest we have. How big do you guys think it is? Anyone guess?
huge.
Huge. As big as the magnet?
1,000,000 Teslas or something.
1,000,000 Teslas. So the space that this magnet has for experiments is 4 inches. And that's about as big as it can get.
Wow.
Because the smaller the center is, the stronger your magnet gets. And so we have to find a balance between how strong do we want our magnet to be and how big can our space be. A lot of magnets have less than 40 millimeters of space, less than a few centimeters. And so this magnet is great because scientists see it and they're like, wow, I could put an animal in there. And they do. We put mice in here. This is a lot where a lot of our biological experiments happen because small mice fit, small birds fit, frogs. This is where we can study brains and we can work on studying cures for diseases because we can see how medicines affect the brain. And the other really important part of this magnet, it says 900 megahertz. So if I were to say 900 hertz, that would mean that it's happening 900 times per second.
Wow.
So in this case, whatever is inside that magnet is being magnetized, is being turned into a magnet 900 million times per second. I can even count to 10 in 1 second. So think about everything that's inside the magnet is the magnet's trying to turn it into a magnet 900 million times a second. And that's what gives us such a clear picture, is when it's turning it into a magnet and it goes back to normal, because we can't turn mice into magnets. They're not going to pick up paper clips after you put it in the magnet. They go back to normal as quickly as they can because their atoms like to be the way they are. And so when they go back and forth quickly like that, that's how we get our pictures. Actually, there is a good picture over here of, this is a mouse print taken by this magnet. And you can see it's an incredible amount of detail for something as small as a mouse.
Wow.
And so that's something that this magnet does that a lot of magnets can't do. This is a pioneer in this field. There are no magnets like this that are this strong anywhere else in the world. So, as far as magnet labs are concerned, there are 9 in the world, and there's one on this half of the world. So, if you wanted to go anywhere in North and South America to go to a magnet lab, you would have to come here. All the other ones are in Europe or they're in Asia. So there are not any on this half of the world besides this one. Now, everyone come over and look at the floor. What do you see on the floor, those big lines?
Yep.
So those are showing us where the magnetic field is.
Okay.
So there's 12 inches in a foot. There's 10,000 Gauss in 1 Tesla. And so that's kind of their divided measure. It's like a million Tesla, but it's 10,000 Gauss in 1 Tesla. So the yellow line is where you first enter the magnetic field that we can measure, and it's 10 Gauss. So nothing happens there, but it's just telling you, hey, you're walking into a magnetic field. The red line is 50 Gauss. That's where, if you're carrying your computer or your credit cards, it will be erased. So you walk past that line, your credit cards are now useless, and your computer no longer has anything on it. So if you're trying to clean out your computer, good way to do it. Not really. It erases all of the structural software too, so it's not a good idea. But it'll also, I don't think it erases your phones, but it will mess with your phones. Your phones will not work the same after they go in and out of that magnetic field.
Remember that guy who stabbed him?
Because,
What?
so scientists don't get to say
Well, it'll be
always
okay.
a
We'll
lot
take care of it.
because
Does it look
there's
bad?
always an exception.
Yeah, it doesn't look bad.
But in this case, I can say always. Wherever there is electricity, there is always also a magnetic field. So your phones have a magnetic field, your watches have a magnetic field, computers, projectors, anything that has electricity also has a magnetic field. And that's one reason your phones are affected by it, because they have that electricity. Even we have very, very small magnetic fields because our brain sends electrical impulses to the rest of our body, right? And so it creates a really, really small magnetic field. Not big enough to attract anything. We can't attract paper clips or attract any kind of iron or magnets, but it does have a very small magnetic field. And then the yellow and black line. So the yellow and black line is 100 Gauss, and that's where the really cool stuff happens. If I were to walk in with a handful of paper clips and step across the line, they would fly out of my hand and stick to the magnet. And
Would you ever be able to get them back?
the only way you could get them back is to turn the magnet off. You turn the magnet off when it's a magnet. So it's an electromagnet. And what that means is it's powered by electricity. When I turn the electricity on, it turns on the magnet. It becomes a very powerful magnet. But when I turn it off, it's just a metal cylinder.
Big coil copper.
Big coil of copper, exactly. And so, the only way to get those paper clips off is to turn that magnet off because it's way too strong to pull off. So, all of the magnets you'll see today are electromagnets. They run on electricity. Now, if I tell you that we have the most powerful magnet in the world, and it's an electromagnet, how much electricity do you guys think we use?
100 million watts or something like that.
A lot of electricity. So,
Very expensive
someone
electric
that
bill.
knows their month's electricity bill, someone tell me what theirs is.
76.
76? That's really good. Mine is not that low.
Uh-huh.
So 76,
300 a month.
150, 250, 300. So it ranges anywhere from $75 to $300 a month to run a house. Mine, my apartment
284?
with 3 other girls, what?
284?
284, good. Mine for a house of 4 girls is 250. Our most powerful magnet by itself costs $4,000 to run
For how long of a time period? would that
for an
be?
hour.
Right.
So for 1 hour, just that magnet by itself costs $4,000 to run. And we run,
Turn it on.
so we only get to run that one about 6 hours a day, 5 days a week. So we are very careful. If we were to turn on every magnet in the building, we would cause a citywide blackout. So, and then Tallahassee would hate us because they would not have AC. So we don't do that.
Wait, I'll show you that here in a minute.
In fact, we often run our magnets in the middle of the night because that's when less people are using electricity, and we have worked out a deal with the electric companies to say we'll use them during